Yeah, so graphs. Y equal to x line. I think you already know this. It's a straight line. The specialty of this is it is symmetric, like exactly in the middle. This is 45 degrees. Total angle is 90 degrees, right?
Yes.
So it's exactly in the half, in the middle. That is the specialty of y equal to x line. Y equal to minus x line. Can you guess how will the graph of this will be?
It will be opposite.
See, x changes to minus x, right? So reflection across.
The y-axis.
So this is the mirror. Y-axis is the mirror. So this comes like this, and this part comes like this. So this is y equal to minus x line. Okay. Yeah, that is also a straight line. Next. So that is about y equal to x. What about y equal to x square?
That creates a parabola.
Parabola. Vertex here is
Origin.
so U-shaped curve. I think you know already. This is called vertex. 0, 0. Okay. Yeah, this is. See, if x changes to minus x, the formula is still the same. X square only, right? So symmetric about y-axis.
Why?
Now let's talk about y equal to x cube. See, if x square was something like this, okay, x cube will be like this, or it will be something like this.
Okay.
Can you guess what is this point called? Point of intersection? This is y equal to x square, right? This is y equal to x cube. What is the point of intersection?
Y equals x.
X values will be how much?
X will be 1.
1, right? See, x cube is meeting x square graph. So either x is equal to 0 or 1.
Okay.
So x equal to 0, they are meeting here, and x is equal to 1, they are meeting here. Okay. So why did I draw y equal to x cube slightly below in the beginning? See, this is an important concept. Try to understand this. Let's say if you talk about a number which lies between 0 to 1, pick any number between 0 to 1.
1.
Between 0 to 1.
Oh, 0.5.
0.15. Okay. Okay, let's say if x lies between 0 to 1, say x is equal to 0.5. Let's talk about x square. What is the value of x square?
0.25.
The value x to x square increased or decreased?
Decreased.
Decreased, okay. So whenever a number which is between 0 to 1, if you increase the exponent, its value decreases. That is why. Do you understand that?
Oh, so then that's why it takes like a bit more like.
It will take time.
Okay.
But once it crosses 1, x is equal to 1, it will pick up the pace. Do you understand?
Yes.
So that is the understanding. So for x less than 1, x power 2 is greater than or less than x cube? Can you answer?
Is less than,
You're saying
or x squared. No. So x squared is is greater than x cubed.
okay, and x square is less than x. Okay.
Okay.
So similarly, it's like that only. X power 4 will be inferior. So on. Okay. So this is only when x is less than 1. Obviously, x is greater than 1 means like this. Okay.
Okay.
So between 0 to 1, the graph of higher exponent x cube graph will be a bit below.
Okay.
This, so the smaller exponent dominates. So that is the nature. These are like important points. Let's talk about now cube. Yeah, x cube, right?
Yeah.
So first we have understood how the graph will be in the first quadrant. It will be something like this. This is y equal to x cube. Okay. This function is even or odd?
This function is odd.
Odd, right? Odd means
Yes.
symmetric about?
The x and y.
Yeah, we call it usually origin. Symmetric about the origin. Yeah, x and y means you can do it like this, and then you have to flip like this.
Okay.
So this graph flips about the origin.
Okay.
Yeah, you can do it like this also, x and y. So this is the main graph.
Okay.
It will be something like this. Okay. Yeah. So odd function, it will be like this. So x cube graph will be something like this, which is important to remember. Okay.
Okay.
Let us understand exponential graph. Y equal to b power x. Let's take one example. Let's say 2 power x. Okay. Do you know how the graph of this exponential function will be?
No, I don't.
Okay. So simply plot x and y values, pick some numbers, and let us trace the graph. Okay.
Okay. 1, 5, 10.
1, 5, 10. Okay. Well, pick some negative values also. What about 0, x-intercept, y-intercept, like that?
-2.
Okay, before that 0 and then -2. Okay.
And then, okay.
Okay. Now let's fill this table. For x is equal to 1.
2.
2, right? 5.
25.
3.
Oh, sorry. 32.
What about 10?
100.
See again. 2 to the power 10, that is, not 10 to the power 2.
That would be 1024.
2 power 10, 1024. And 0?
Oh, that would be 0.
See again. 2 to the power 0, that is.
1.
2 to the power 0 is?
1.
What about 2 to the power -2?
0.25.
2 power negative 2 means 1/4, 0.25. Okay, did you understand why it is for 0, 1?
Yes, because anything to the power of 0 is 1.
Okay, so obviously, so 1 comma, so you have chose 1, 5, and then 10 is somewhere far away. So 0 is here, negative 2, right?
Yes.
So for 1, value was
2.
2. So this is the point. For 5,
32.
very far away. For 10,
And then 1024, so very far
somewhere
away.
very far away. So this is the point. For 0,
1.
so it's around here, right? For -2,
Well, 1/4.
can you spot that point?
Right.
Negative 2 comma
Yeah.
0.25. Yep. So what do we need to do after plotting these points?
Trace them.
Yeah, join those. And
So this is exponential graph.
yeah, exponential graph, it will be like this. Exponential graph, there are different conditions. This is a case when base is greater than 1. Base. The value will be different when base is between 0 to 1.
Okay.
0 to 1 to the power something. We just discussed how the nature changes. So for now, okay. Will this ever cross? Will this ever come down the graph?
No. No.
And why not?
Because the asymptote is the x-axis.
Well, how do you know that? That is the asymptote.
Because as you're going to like as you're going to like numbers like once you reach like -2, then it keeps going in decimals and getting smaller and smaller. Yeah. So it'll never be able to reach 0 then.
Okay. One other way to look at it is, say something to the power x, exponential function, right?
Yes.
It can never be negative. It is always positive. Assuming the base is positive, so 2 to the power anything is always a positive quantity.
Okay.
So exponential functions, outputs or y values are positive. Base, assuming the base is positive. You know what is base and what is exponent, right? This is the base. This is called exponent. What is down is called base. What is up is called exponent. Pretty obvious. Yeah, that is why the value becomes small as you go left, but it will become like 0.0001, but it will never be 0. So that is the asymptote.
Okay.
So to find the asymptote, there are 3 types of asymptotes. Yeah, we'll discuss later regarding asymptotes. For now, graph is the priority. So that's about b power x. Yeah, let's talk about Same, y equal to b power x. We just discussed when base is greater than 1, right?
Yes.
See, in exponential graphs, we only talk about positive bases. Okay?
Okay.
So 0 is here, 1 is here. We just talked about this case, after 1. So we don't talk about this. So this is left,
Okay.
0 to 1. See, 0 to 1, it's interesting because what did we discuss just now? If you increase the exponent of a number which lies between 0 to 1, what happens?
Becomes smaller.
Smaller. So the graph of y equal to b power x earlier was like this. So as the value of x increases, y increases, right? Yes. For b greater than 1. Similarly, if b is less than 1, as the value of x increases, okay, for b less than 1, as x increases, y, what happens?
Then y goes up.
Y increases or decreases?
Y decreases.
Decreases. So y decreases. So the graph will be the same, except that it will be different like this.
Oh, okay.
That's it. So this point, but is common for both. Can you guess the coordinate of this point?
1.
Yeah, 0, 1. Why it is 1 for both?
Because any number to the power of 0 is 1.
So base to the power 0 is 1. Provided b is, yeah. So anything to the power 0 is 1.
Okay.
Okay, yeah, so this is about exponential graphs. Same asymptote is still the same, x-axis. Okay. So next is, we discussed x cube exponential function, absolute value of x. You know this graph?
Yes.
Okay. Yeah, almost done, I guess. So can you draw this on here? Can you draw y equal to, let's say, minus absolute value x?
Okay.
So basically, if you know the formula, if you know the diagram for this, which is this, no, y equal to absolute value of x. You already have that graph, which is this. So
Yeah.
by extension, if I want to draw the graph of minus absolute value of x, so y became minus y. Okay. So that means it is reflection across
The y-axis. Or x-axis.
x-axis. So that is why it is inverted. X-axis reflection, that is. So yeah, here to here, y became minus y. What axis? Reflection across
X-axis.
x-axis. So I think you understood, right?
Yes.
Okay. Now, before we talk about square root, cube root, and logarithmic functions, Let us understand the concept of inverse functions. You know this?
No. Actually, I think a little bit. I should recall.
Well, inverse functions. Okay. Let's say f of x and g of x are inverse functions. Are said to be inverse functions. Then their composition is x. Composition means composite functions. F circle g or g circle f. It's a composition. So instead of f of x, I put g of x. So g of, instead of x, we have to put f of x. So both the values have to be x. Okay.
Okay.
So the condition is both. So f of g and g of f have to be same, x value. Let us understand how. See. So for that, composition is important. How to evaluate, how to find the composite functions. I think there were some questions in the mock test.
Yeah, there were some questions.
Okay. I have since you have done some of that. Let's understand what that means.
Okay.
So let's say f of x is equal to x square plus 1. And let's say g of x is equal to root of x minus 1. Check if question is the same topic. Check if f and g are inverses of each other.
Okay. Uh, uh, then
X, right?
yes.
See, you have to put the bracket here, okay?
Oh, okay.
Root x minus 1 is being squared.
Yes.
Yeah. Square root is negated by the square.
And then we have to solve for g f of x.
So g of f of x
Is equal to g, and then parentheses x squared plus 1.
So there's no need to write in that elaborated manner. I'll tell you the trick. G of f of x, right?
Yes.
See, g of x was root x minus 1. So wherever there was x, notice where is x? Here is x, right? So wherever there was x, we plug it back with f of x. So it's the same as, when g of f of x is the same as square root of, instead of x minus 1, f of x minus 4. So wherever there was x, replace that with f of x.
Okay.
And f of x was what?
F of x was x squared plus 1.
Yeah, so x squared plus 1. So try it. Okay, x square plus 1 was f of x. There was minus 1 also. Can you see directly x?
X.
Root of x
Yes, you can do
square.
that. Yes.
So the final value is x. So that is why.
So they are.
So they are inverses of each other.
They are okay.
So it's like f of g of x is equal to x. G of f of x is equal to x. The way we represent that is inverse, right? We call it inverse.
Okay.
So this, if you want to shift it to the other side, it will be like this. So f inverse of x is equal to g of x, like this. So if you f inverse of on both sides, so f inverse f goes out, g of x is remain.
Okay.
So like that. So from here, can you write like this? How did we write this? Try this here also.
Okay.
Yeah, that's it.
Okay. Yeah.
So what did we say? Check if f and g are inverses of each other. So you have to check for both conditions, f of g of x, g of f of x. Both condition, if they become x, then it is valid. Fine. So that is the thing. Now let us understand the nature of inverse functions. Inverse functions, try to understand this. This point is extremely important. Inverse functions in the graph are symmetric. They follow a pattern. They will be symmetric about y equal to x line. Okay,
Okay.
y equal to x line. Y equal to x line was a 45-degree line, correct?
Yes.
See, whatever the function is, okay, let's say a graph is something like this. Okay, f inverse. Can you draw f inverse?
Um. Would it be like this?
See, this is the f, not the straight line. See, this is y equal to x graph. Okay, y equal to x line. This is like
Oh.
mirror axis of symmetry.
Okay.
So the graph
Oh.
of
Oh.
f is this.
So that would be. I'm not sure. Would it be like this?
See, it's like taking mirror images only, reflections. Let's say there is an alphabet B here. If there was a mirror like this, what will be the symmetry? Draw it. Mirror image.
Like this.
For alphabet B, if this is the mirror,
Oh. Sorry.
yeah, symmetry, yeah. So if there was a, so this is a bit slightly inclined.
Oh, so then it would be like.
That's it. Okay. So
Oh. Okay.
see, you have to draw a perpendicular like this. So it starts from here. So it will be something like this to be accurate. Okay.
Okay. Okay.
Somewhere around like this. So you see that, right?
Yes.
So if there was a mirror like this, you'll draw like this. It's what is happening here. It's just that the mirror is tilted 45 degree. So this is F inverse, okay?
Okay.
So if you understand this, concepts will be extremely easy. So the nature of inverse functions, g of f of x, these two conditions, f of g of x, they have to be x. And then the graph nature will be, they'll be symmetric about y equal to x line.
Okay.
Okay, let us find inverse of, let's say, first things first, square function. Square function inverse, let's say y equal to x square. Can you find the inverse of this?
Okay.
Okay, you know the graph of y equal to x square is something like this, right?
Yes. Would it be
For now, let's consider this diagram.
square root x? Root x.
Yeah, root x only.
Okay.
See, diagrammatically, can you draw it?
Um. Oh. So it feels like
This is x square graph. To draw inverse, what to do?
reflected across
Across.
y equals x.
So where is y equal to x? Draw it. Draw the mirror. Yeah. So take reflection. That's it. So this is the graph of, okay, this is the graph of y equal to inverse function of square, which is square root x. So like this, it will be like this. And yeah, that is the graphical way. Analytical way to solve analytically to obtain the formula of inverse. To obtain inverse analytically, inverse function, by solving with variables, what we do is, we, wherever there is a y in the formula, we replace that with x, and wherever there is x, we replace that with y. So in the formula, y equal to x square is the graph, right? I mean, the formula is y equal to x square, square function. To obtain inverse of this square function, this is the method. To obtain inverse function, what do we do?
We make y equal x and then x equal y.
So interchange y with x with y. Okay. So y became, so in this formula, y became x became y. Can you write the new formula?
Okay.
X square equal to?
Well,
Huh?
nothing. Sorry.
See, both are same things only.
Yeah, that's what I was thinking.
Y became x, right? So wherever there was y, you put x there. So it will be x is equal to, not x square.
Okay. X is equal to. So it's just y equals x, correct? Or
And wherever there was x, you have to put what?
y.
So x is being squared. So remaining as it is. We only change x and y, put everything else as it is.
Oh, okay.
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 Yeah. So x is equal to y square. So y is equal to how much?
Y is equal to root x if you square root everything.
So plus or minus root x, but let's talk about root x. So root x graph will be the inverse for square function. And in the diagram, we already know y equal to x square is like this. The mirror should lie along like this. So for this region, it has to come up. And for this region, if you take reflection, it has to come down. When like this. So it will be, this is the y equal to root x graph. Okay.
Okay.
Can you find the inverse of, let's say, cube function?
Okay. Cube root x. Y equals cube root x. Or cube x.
So wherever there was y, put x. Wherever there was x, put y. And remaining everything, whatever is there, drop it as it is. So x is equal to y cube, y equal to cube root x is inverse. So cube root x.
Okay.
So can you draw y equal to x cube here first? Y equal to x cube.
And then cross this line, it would be
Let's see the entire graph of y equal to x cube. Draw like this here. This is the graph. It will be like this. So it will not go like this. Okay. It will not go like that. It's a bit free like this.
okay.
Yeah. So basically, graph will be like inverted like this. So cube root x. Okay.
Okay.
This is the graph head. So that is what I have drawn. Okay. So try for exponential function also.
Okay.
Okay. That is the homework.